Okay, by the end of last lecture, we have successfully configured the fencing device that is going to be used by our cluster nodes. Let's now start by creating the shared storage, the actual storage that is going to hold our application files. So now we have a raw disk. Let's use fdisk again, -l, grep sd. As you can see here, we have SDB and SDC. We've already used the SDC disk in order to create the fencing device. Now we need to use the SDB to create our shared storage. So let's use this disk by entering fdisk -dev -disk by ID, and let's have a look at the WWM of the SDB disk. So let's copy and paste this WWM, press enter. Okay, and we are now inside the disk. Of course, it does not have any partition table, does not have anything. So I'm going to create a new partition table by clicking on the N letter, create a primary partition, accept the defaults. It's the first sector and second and last sector. Gonna use all the disk inside, all the space inside the disk, and don't forget to press W to write those changes to the disk. Okay, and now we do have ls/dev/disk by ID, and if you have a look, let's just paste the WWN again. Now you have, as you can see, the WWN of the disk itself, and then the same WWN. WWN is just a unique ID of the disk over the network. If you have worked with shared storage before, storage area network or SAN, you will be familiar with the term WWN. If you haven't worked with SAN before or with shared storage, this is just a unique identifier of a disk over some network. Now, as you can see here, I have the same disk but with -part1 appended to it at the end. This means that this is a partition of the disk, not the entire disk. A partition has been created. Okay, let's clear the screen, and I'm going just to maximize this window now. I don't use this anymore. Most of the commands that are going to follow are going to be on just one of the nodes. So let's create a file system on this disk by using mkfs-t ext4/dev/disk by ID. Again, let's paste part1. Okay, and it's creating a file system on the disk. Now it has been successfully created. Now let's mount this disk on our, let's just have a copy instead of writing this whole thing again. Gonna just have a copy of this, paste it. I'm going to mount it over /var/www, which is the default web directory of Apache. So it's part1. Okay, and let's create the directories necessary for the HTTP server to work: /var/www/html /var/www/cgi-bin, and also the error directory. And finally, we need to restore con, because we are using SE Linux. So we'll need to restore the configuration or SE Linux configuration over this directory, because this is a special directory and SE Linux might prevent us from using it if it does not have the correct permissions. Now let's umount /var/www, because this is going to be done by the cluster. The cluster is the one that is going to handle mounting and unmounting this directory, this device. And okay, before we unmount it, let's create the default index page. So let's go to var www.html index.html. It's going to be the default page in our cluster. Let's create just a very, very simple HTML file. HTML body. Inside the body, let's create an h1 tag. Welcome to CentOS cluster, or any welcoming message that will just ensure that you are correctly arriving at the web server and it is up and running. Now let's close the body, close the HTML tag, and save the file, and you mount, of course, /var/www. Okay, so now I have my file system ready. Let's clear the screen. Now it's time to create a resource out of this file system. So before we go anywhere else, let's just have a look at /dev/disk/byid. Okay, and we need to take a copy of this wwm because we're gonna need it when we create the resource. So just ensure that we have copy of that. And let's use PCS resource create web server _fs for web server file system. File system device equals, then I'm going to point to the device that we have just taken, that we have just copied its wwm, like this, and the directory that the cluster will mount this device at is /var/www. The fs type, because this is gonna be needed, is of course ext4, and the group that this resource is going to be under, let's call it Apache group, like this, Apache group. Press enter. Okay, this is going to create this resource. If I type PCS resource show, I'm going to have this web server _fs. This means that I do have a resource now that is active. Now, in order for this to work, the cluster needs some way or some means of ensuring that the web server is up and running. So, Linux cluster or the pacemaker by default uses a special file in Apache that is called server-status. You will need to enable this page or this functionality in the Apache web server before it can work. So let's go to /etc/httpd/httpd.conf, and at the end of this page or this file, this is of course the default configuration file of Apache, we are going to paste this text. Location server-status. This is a well-known location that the cluster or the pacemaker by default navigates to. We are just setting a handler, a special handler for this specific URL. It is called server-status. And of course, I'm going to allow only connections from the local host to access this server status because it contains vital information about the web server. Of course, something like that should never be displayed in public. It should only be displayed for connections coming from the local host, typically coming from our cluster. Let's save that, and we will need to do that same thing on the second host or on the second node. So let's quickly log in. And you just can use sudo /vim/httpd/httpd.conf, and let's enter the password, go to the file, paste that text. Okay, now on both nodes we are going to issue the firewall command or firewall cmd --permanent that is going to ensure that -add service equal HTTP. The HTTP traffic is going to be accepted, which is port 80. And of course, you will need to run firewall -cmd -reload. Of course, this has to be run using sudo. Okay, and on the other machine, 192.168.56.102, which is the first node, you will need to enter the same commands. So firewall -cmd -permanent -add -service HTTP firewall cmd -reload. Okay, Now we have successfully created our storage device or our storage disk. We added this as a resource to the cluster. Now the cluster is aware that it will need to mount a device under /var/www, and it's going to do this on the active node. We have also configured the Apache web server to serve the server-status, which will display by default health information about the instance of Apache that is running. The cluster or the pacemaker is going to use this information to determine whether or not Apache is running on this node or not, and accordingly to take the appropriate action to move the resources to another node if this node fails. Now in the coming lesson, we are going to configure our second resource in the cluster, which is the shared IP address. So until next lesson, take care. Alright, let's now create the shared IP address. This is the second resource that we will need to add to our cluster or to our pacemaker. We can do this easily by using the following command: pcs resource create _res, which is the virtual IP resource, IP_ADDR2 IP equals, then I'm going to give it the IP address that it will be used as a shared storage. I'm gonna use 192.168.56. We've used already 110 for our iSCSI target. Let's use 120 for the shared IP address. CIDR for the net mask. It's gonna use the CIDR notation, so you can add the prefix. 24, of course, is class C network. -- group. Of course, you're gonna give it the same group that was used for the shared storage, which is the Apache group. Press enter. Okay, and now we have the resource created. Now finally, we can add the Apache resource itself, which is the web server. PCS resource create Apache _res for resource, Apache config file, give it the path to Apache configuration file, which resides as @/etc/httpd conf, then httpd.conf. Then notice here the status URL that we are going to give to the cluster, http 127.0.0.1 -server-status, and of course -- group is Apache group. Press enter. Okay, now we have three resources created: the storage resource, the VIP or the virtual IP or the shared IP resource, and finally the Apache resource, which is going to use the underlying resources, the storage and the VIP, to serve Apache as a web server. Now if I typed PCS status, you're gonna see that the output is much longer than before. Now we have four resources configured. We have the resource group Apache group started. On CentOS 1 we have the web server file system started, the VIP resource started, and the Apache resource started, all on CentOS 1. Now if I go to the browser, let's open Firefox, new tab, and if I navigated to the VIP IP address 192.168.56.120, I'm gonna see that I have welcome to CentOS cluster display. This means that the cluster has successfully been able to mount the file system, start the Apache web server, and use the shared IP address in order to serve the web content. If I go back here to the node, let's clear the screen, and if I used IP_ADDR, I'm gonna see that I have, in addition to the IP addresses of the machine, I'm gonna have an alias IP address. Let's have a look here. 192.168.56.120/24. This IP address has been automatically added by the cluster to this node, and of course, and also if I ran df-h, I'm gonna see that I have /dev/sdb1 mounted automatically to /var/www. This has been automatically also done by the cluster. Okay, so far I have the cluster working and it's serving my content. That is nice. However, I do have to add the other node to the cluster. So in order to do that, I can use the GUI mode of the cluster or the GUI interface of the cluster, which can be accessed through its VIP IP. However, I'm gonna add first the port 2224, and I will have to access this interface using HTTPS. It's gonna ask me, of course, this does not have a certificate, so I'll have to add an exception, and it's gonna ask me immediately for my credentials. Going to add the user and password that I have created earlier in this section, HA cluster, and the password that you have set, login. Okay. And from this interface, I can add the second node in the cluster by clicking on this Add Existing. Now let's give the IP address of the second node or the host name if you wish to. You can just add the host name, CentOS-2. Click on Add Existing. Okay. And now CentOS-2 has been added successfully. If I click here, I'm gonna see that I have both nodes now added to the cluster and everything is running successfully. Now, watch what happens if we want to move the resources from one node to another. So here, if I type PCS status, okay, everything is started. So I'm going to keep refreshing this page, and I'm going to use PCS cluster stop CentOS-1. Going to stop this node. And while doing so, I'm gonna keep on refreshing this page. As you can see, the page is refreshing without any problems. Service is retained. In a few moments, you're gonna see that CentOS-1 is going to be in red. Still, page is refreshing. Okay, as you can see here, it turned red, while the service is still running. Nothing has changed. Okay. If I go here and I type PCS status, okay, I'll have to open another node, go to 2, okay, SU, PCS status. Okay, everything is started on CentOS-2, on node 2. If I go back here, and if I go to PCS, type cluster start CentOS 1. Again, let's go here, refresh the page. Page has not been interrupted for a second. In a few moments, you're going to see that CentOS-1 is going to be turned to green. Session has expired. I'm going to log in again. Okay, as you can see, CentOS is turning green again now. Both of them are now running. If I go to any of the nodes, type PCS status, I'm gonna see that everything now, the fencing device is at CentOS-2 while all the resources are on CentOS-1. But what if I stopped CentOS-2, PCS stop CentOS-2, or even if I powered off the machine altogether like this, power off. Let's observe what happens. Service is not interrupted. Okay, CentOS-2 immediately turned to red. Service is not interrupted here. I believe the machine has gone down now. Okay, it's powered off. Let's start it. Okay, it's up and running now. Now both nodes are back. If I go to the terminal now, PCS status, and let's do the same thing, but this time I'm gonna do it on node 1. Power off, like this. Again, let's have a look at the service. Service is still running. It's not interrupted. While this will immediately now turn to red, indicating that CentOS-1 is now out of reach. Still having a service. Nothing has been interrupted. As you can see, it turned red. While in here, we are still having the service with no interruption at all. Now let's bring back CentOS-1. The node is up and running, and now it's gonna turn blue. As you see, both nodes are now online, and in all cases, we do have a service here. The web server is running. It has not been interrupted even for a second. When the second node went down and when the first node went down, cluster is intelligently moving the resources from the failing node to the active node in order to avoid any service interruption. That brings us to the end of this lesson and to the end of this section in projects in Linux. This section was titled Using Linux for Clustering. My name is Ahmed. I hope you enjoyed this section and see you next.